Hi there. Today we're going to be looking at equivalent fractions and we're going to start with a question. What does the word equivalent mean? The term equivalent in maths refers to two values, numbers or quantities which are the same. We're going to get that statement down. So the term equivalent refers to two values, numbers or quantities that are the same. First key point, feel free to put a box around it, use your highlighter pens, however you want to make it stand out. Okay, so we know what the word equivalent means. What about an equivalent fraction? So next question, what is an equivalent fraction? I'm just going to underline that. As usual, you know the score in terms of setting your work out neatly, underlining your date and title and any subheadings as we go. Okay, so an equivalent fraction, so tell me if I spelt it correctly, an equivalent fraction is a fraction that has the same value even though it looks different. So an equivalent fraction is a fraction that has the same value even though it looks different. Right, okay, so maybe we could have a little look at an example. So let's draw out a quick rectangle. Actually, let's make it a square. Doesn't really matter. It's just representative. I'm going to do a 4 by 4 square. Okay, that's my hole. If I cut it into 1/2, and let's just shade 1/2 of it. I'll find a highlighter pen. So I have shaded half of my shape, okay? One part shaded out of 2 equal parts. Now I can also split my square again this way. So now I have 2 shaded parts out of 4 parts in total. I could split it again. Again, the parts must all be equal. I now have 4 shaded parts out of 8 equal parts in total. Okay, so that's what an equivalent fraction is. How do we find them? So next subheading, finding an equivalent fraction. Okay. So, another sentence in our books. Equivalent fractions, they can be found by either multiplying or dividing both the numerator and the denominator by the same number. So equivalent fractions can be found by either multiplying or dividing both the numerator and the denominator by the same number. So let's have a look at the example that we had here. For example, if I have 1/2 and I want to create an equivalent fraction of 2/4, I need to multiply my numerator and my denominator by the same number, in this case 2. So my equivalent fraction is going to be 2/4. So I've taken a fraction which is in its simplest form and I've expanded it to get 2/4. Right, just move it over a little bit. Hopefully you can still see. Let's have a look at one of the other ones. If I started with 4/8, I could simplify it back to 1/2. So this time I have divided the numerator and the denominator by 4. So I have simplified. Just been joined by my dog, so apologies if I'm a little bit distracted. And you'll often see with a question where you're given a fraction, you're asked to write it in its simplest form. You're often asked to simplify a fraction and it will ask you to write the fraction in its simplest form. I'm going to have to move my book so you can see that. You can't quite see it, can you? There we go. Okay. Let's do some quick examples. Nice and easy, but just to practice what we're doing. So if I start with 3/6, we know that 3 is a factor of 6, or indeed 6 is a multiple of 3. Both numbers are in the 3 times table, and therefore I can divide both the numerator and the denominator by 3, which is going to simplify my fraction to 1/2. Let's try another one. I start with 10/15 as my fraction. Again, I know that both of those numbers are in the 5 times table, so I can simplify them by dividing by 5. 10 divided by 5 gives me 2. 15 divided by 5 gives me 3. Let's just do one more quickly. Let's do a negative one. Same principles apply. I've got -16/18. They're both in the 2 times table. So let's take a look at that. Always, if you've got even numbers, simplest thing is to divide them by 2 and then see whether there's a further simplification you can do. In this case, once you've divided by 2, you will see, do not forget your negative sign. You're going to have 8/9. It cannot be simplified any further. Okay, what about if we had a mixed number? Let's have a quick look at one of those. Sorry, we're creating a mixed number from an improper fraction. So I've got 12/10. Okay, so we've already done conversion from mixed numbers into improper fractions and improper fractions to mixed numbers. 10 goes into 12 one time, remainder 2, and then I can simplify that down to 1 1/5. Alternatively, I could have simplified it first. 12/10, I could say, well, I can simplify that to 6/5 because they are both even numbers, so I can divide by 2. And then I can say that 5 goes into 6 once, remainder 1, which leaves me with 1 1/5. Going the other way, starting with a mixed number, in this case 1 and 5 over 10. Again, I've got two different ways of doing it. I can do the conversion into an improper fraction first. 1 multiplied by 10 is 10, plus 5 gives me 15 over 10. And then I can simplify it down. Very similar to question 2 up here. I'm going to be dividing the numerator and the denominator by 5. That's going to give me 3 as my numerator and 2 as my denominator. Again, there's an alternative way of doing it. I can do the simplification first. So I start with 1 and 5 over 10. I simplify it to 1.5 first. And then I do 1 multiplied by 2 is 2. Add 1 gives me 3 over 2 as my improper fraction. All right, just to finish off, I just want to quickly talk about comparing fractions. So this is our last little subheading for today's lesson. Comparing fractions. Okay. The way we normally do comparing fractions is if the denominator is the same, okay? So we're going to call this the same denominator method. And we're going to work out in this particular case which is smaller. Which is smaller. Okay, so let's start with the first one. Question 1. Again, I'm going to move this a little bit so you can see. Bear with me. Okay, question 1. Which is smaller? I'm comparing 1/2 and 2/3. Okay, let's have a look at it and see. I need to create equivalent fractions with the denominator the same. So the simplest way to do that is to multiply my two denominators together. If I do that, then I'm comparing 1 over 2 becomes 3 over 6 because I'm multiplying the numerator and denominator by 3. And 2 over 3, this time I'm multiplying by 2, is an equivalent fraction of 4 over 6. I can therefore see that 3 over 6 is less than 4 over 6. So 3 over 6 is the smaller of the two fractions. Just need to move my book a little bit more so you can see the bottom of my sheet. All right. Let's see what happens with this example. 7/8 and 5/6. Now this time we could do the same thing. We could multiply the denominators together and create what we call a common denominator. But what we want to try and find is the lowest common denominator, just like we did lowest common multiple earlier. So we need to count up in our 6 times tables until we get a multiple that's also in our 8 times tables. So 6, 12, 18, 24, 8, 16, 24. So my denominator is going to be 24. Actually, let's write it so you can see. So 7/8 with a denominator of 24. I've had to multiply 8 by 3 to get to 24. So if I do exactly the same for the numerator, 7 multiplied by 3 gives me 21. Let's do the same again for 5/6. But remember, I'm not multiplying by 3 this time. To get from 6 to 24, I need to multiply by 4. So I'm multiplying my denominator and my numerator by 4. 5 multiplied by 4 gives me 20. 6 multiplied by 4 gives me 24. I can therefore see that 20 over 24 is less than 21 over 24. Now, one thing I need to mention is when you're doing comparing fractions, you always want to go back to the original fraction. So, for example, here where I've got 20 over 24, that's telling me that 5/6 is less than 7/8. Okay. Similarly, back up here, I should have said earlier, 3/6 was 1/2. So 1/2 is less than 2/3. Okay, so hopefully you can see that. Right, I said I was going to do one last example here. Let's see what happens if we make the numbers negative. So we have negative 7/8 and negative 5/6. Okay, we know from what we did before that we've got 20 over 24 here. So let's write that there. We don't need to work that out again. And for 7/8, that was 21. So now we've got 21 over 24. Now, the best thing to do with a question like this, if you're not quite sure, it's really easy to make a mistake with a question like this. So what I would do is just draw a very quick little number line. It doesn't have to be to scale, it's just approximate. We know that positive numbers go to the right, so let's, I don't know, it doesn't really matter. We'll just make that 1 and that 2. And negative numbers go to the left. Negative 1, negative 2. Okay? So now we know that the further away from 0 you are, the smaller the number is if you're moving to the left. So let's look at this. Negative 20 over 24 is going to be closer to 0 than negative 21 over 24. There's not much in it, but you can see that, I can't really write this in, negative 20 over 24 is closer to 0 and therefore larger. So remember, when you're looking at negative numbers, it's the number that is closer to 0 that's larger. So if we're looking for the smallest out of these two, this time instead of 5/6 being smaller, it's going to be negative, run out of space at the bottom here, sorry, negative 7/8 that is smaller because it is further away from 0. So just be really careful with those negative numbers because you can get unstuck. So typically that's what we do. However, there is one other thing I just want to mention. I've run out of space there, let me do it down here. Just one more thing to mention. That you can compare fractions by comparing the if the numerator is the same, by comparing the denominators. So comparing fractions when numerator is the same. Now the easiest example here would be if the numerator was 1. So very simply here, if I am comparing 1/2 and 1/4, and I want to know which is smaller, okay, think about my, I don't know whether it's a cake or a pizza or what have you. The first one I'm cutting into 1/2. So this is the size of my piece of pizza or cake. This one I'm cutting into quarters. Okay, so the basic rule here is the larger the denominator, the smaller the piece. Okay, 1/4 of a piece of pizza is going to be smaller than 1/2 if your whole is the same. Okay, so we can compare fractions when the numerator is the same, because the larger the denominator, the smaller the fraction. Okay, so let's just write that as our last sentence of this video. When the numerator is the same, the smaller fraction is the fraction with the larger denominator. Okay, i.e. the pizza has been cut into more slices. If it's been cut into more slices, then each slice is going to be smaller. Okay, so I'm going to pop that in my little key point bubble as my final point of this session. And it doesn't have to have a numerator of 1. I did say that was your last bubble, but very, very quickly, one last point. So if I had 3/4 and 3/5, I don't even need to draw it. I can just look at it. I don't need to use equivalent fractions. I don't need to convert into decimals. And I can see that 3 pieces out of 4 is bigger than 3 pieces out of 5. So that's a little top tip for you to finish off this session. Thank you very much.